Hello, viewers. In today's session, we are going to discuss a very important and very conceptual problem from domain of functions, right? And here we are given a function y, which is equal to square root of 2 times cos inverse x minus sine inverse x, and we have to find the domain of this function y, right? So by domain of a function, we mean that all the valid values of x, right? So we have to find all the values of x which define this function y. So here we have a combination of two inverse trigonometric functions, and we'll see how we can find out the domain of this function y with the help of using the properties of inverse trigonometric functions, right? So let us start. So here we see that we have the expression 2 cos inverse x minus sine inverse x inside the square root sign, right? So whenever we have a number, say square root of a, then for the validity of this number, that is, if we want to express this square root of a in the set of real numbers, then this a must be greater than or equal to 0, right? So this is the condition for having this number, or having this expression square root of 2 cos inverse x minus sine inverse x to be in the set of real numbers, right? So the first condition is that this number, that is 2 cos inverse x minus sine inverse x, must be greater than or equal to 0, right? So now here we have this inequality, and now we'll proceed from this inequality to get the domain of this function. So let us solve this inequality step by step. So what we can do, let us substitute here cos inverse x as pi by 2 minus sine inverse x, right? So here we have sine inverse x, and here we have greater than or equal to 0. So here we have used an important property of inverse trigonometric functions, that is sine inverse x plus cos inverse x is equal to pi by 2 for all values of x belonging to the interval minus 1 to 1, right? So we have written cos inverse x is equal to pi by 2 minus sine inverse x. So here we have this expression for cos inverse x. So now multiplying these two numbers by 2, we have pi, then we have minus 2 sine inverse x. Here we have sine inverse x greater than or equal to 0. So we have pi minus 3 sine inverse x greater than or equal to 0. So let us take this number to the right hand side. So we have pi is greater than or equal to 3 times sine inverse x. So let us rearrange the terms here. So we can take this 3 in the denominator of pi. So we have pi over 3 greater than or equal to sine inverse x. And we can also write this inequality as sine inverse x is less than or equal to pi by 3, right? So this is an important step in this problem, right? So we can call this inequality as inequality number 1, right? Okay, now here let us use one more important result from inverse trigonometric functions, that is the range of sine inverse x is it belongs to the interval minus pi by 2 to pi by 2, right? So sine inverse x must lie between minus pi by 2 and pi by 2, including both these numbers. So we can also write it like this: sine inverse greater than or equal to minus pi by 2, and it is less than or equal to pi by 2. So we can call this inequality as inequality number 2. So now we have to merge these two inequalities, right? Now see here we have sine inverse x greater than or equal to minus pi by 2, right? So here if we insert this part in this inequality, then here we can write sine inverse x greater than or equal to minus pi by 2, right? So now this inequality can also be redefined as the sine inverse x greater than or equal to minus pi by 2 but less than or equal to pi by 3. So what we have done here, from this inequality, we have taken this part, that is sine inverse x is greater than or equal to minus pi by 2. So here we have inserted minus pi by 2 here, so that sine inverse x is greater than or equal to minus pi by 2, but it is less than or equal to pi by 3 due to this inequality, right? So now let us take the sign of all these three numbers, right? So we have sine minus pi by 2, and here we have sine of sine inverse x, and here we have sine of pi by 3, right? So what we have done, we have taken the sine function of all these three numbers, right? So here we have minus sine pi by 2, because sine minus theta is equal to minus sine theta, and here this sine and this sine get cancelled, because we know an important property of inverse trigonometric functions, that is sine of sine inverse x is equal to x for all x belonging to the interval minus 1 to 1, right? So here we are left with only x, and here we have sine pi by 3. So viewers, here we have also an important thing to note, that when we have taken the sign of all these three numbers, then the direction of the inequality, it doesn't change, right? So it remains the same, because the function sine function is an increasing function in the interval minus pi by 2 to pi by 2, right? So sine function is increasing in this interval. So we can also see this fact from the graph of sine function, right? See here we have the graph of sine function, and this is the sine function, and here we have minus pi by 2, and here we have pi by 2, right? So from this point, that is from point A to point B, when we go from minus pi by 2 to pi by 2, then we get this curve, right? And from A to B, the sine function is increasing function. So now the value of sine pi by 2, that is sine 90 degrees, is 1. So we have minus 1. Here we have x, and here we have sine 60 degrees, which is square root of 3 over 2, right? So we have got our domain, that is the domain of this function. So x, it belongs to the closed interval, that is from minus 1 to square root of 3 over 2. So this is the required domain of the function y is equal to square root of 2 cos inverse x minus sine inverse x, right? So this is how by making use of all these concepts, we can easily arrive at the domain of functions. Hello viewers, in today's session we are going to discuss yet another important and conceptual problem from domain of functions, right? So here we have a new problem in which we are given a function f of x is equal to square root of sine inverse x divided by 2x minus 1, and we have to find out the domain of this function, right? So to find out the domain of this function, what we will do, we'll find out the domain of the function that is square root of sine inverse x, and the domain of this function that is in the denominator, which is 2x minus 1, and then we'll find out the intersection of these two domains to get the domain of f of x. So now let us consider first this function, that is square root of sine inverse x, right? Now the validity of this function, that is the square root of sine inverse x, the condition is that the expression which is inside this radical sign, this expression must be greater than or equal to 0, right? Because from simple algebra we know that if we have an expression that is square root of a, then a must be greater than or equal to 0 for square root of a to belong to the set of real numbers, right? So this a is either equal to 0, or it should be a positive real number. Then only square root of a can belong to the set of real numbers, because if we have a negative number inside this square root sign, then we'll get a complex number. So here we are dealing with only the real numbers. So square root of sine inverse x is valid only when sine inverse x is greater than or equal to 0. So now we have this important inequality, right? Now from here we have to proceed further to get the values of x which satisfies sine inverse x greater than or equal to 0. So for this we'll make use of some concept from inverse trigonometric functions. So from inverse trigonometric functions we know that sine inverse x, the range of sine inverse x belongs to this interval, that is from minus pi by 2 to pi by 2, right? So this is the principal value branch of sine inverse x, where this x belongs to this interval, that is from minus 1 to 1. So when sine inverse x belongs to this interval, we can generate an inequality, that is sine inverse x is greater than or equal to minus pi by 2, but it is less than pi by 2, right? Okay, now see here we have sine inverse x greater than or equal to 0. So what we will do, see sine inverse x, it belongs to this interval minus pi by 2 to pi by 2. Here we have 0, right? And we have also these 2 points. So sine inverse x is greater than or equal to 0. So it implies that we have to now take this interval only. That is sine inverse x is greater than or equal to 0, and it must be less than or equal to pi by 2, right? So we have to merge this part of the inequality with this one to get this inequality, that is sine inverse x is greater than 0, greater than or equal to 0, which is our this inequality, and sine inverse x must be less than or equal to pi by 2, which is our this inequality, right? So now we have to find the value of this x from this inequality. So now let us take the sine function of all these three expressions or the numbers, right? So we have sine of 0, then here we have sine of sine inverse x, and then here we have sine of pi by 2, right? So sine 0 is simply 0, and here this sign and this sign it get cancelled, so we have x, and here we have sine pi by 2 which is equal to 1, right? So now we have obtained this inequality, that is x is greater than or equal to 0, but it is less than or equal to 1. So now we have obtained the domain of square root of sine inverse x as x belonging to this interval, that is 0 to 1. And remember, here we have the equality, so these 2 points are included, right? So now let us consider this function which appears in the denominator. So here we have 2x minus 1, right? Now since this expression 2x minus 1, it appears in the denominator, so this function should not be equal to 0, because the moment this uh, expression it takes the value x is equal to half, this expression 2x minus 1, it becomes 0, right? So the expression 2x minus 1 is valid for all real numbers except x is equal to half. So the domain of 2x minus 1, which is in the denominator, the domain is all real numbers except this value, that is half, right? So now we have the two domains. This domain can be represented by d1, and this domain can be represented by d2. So now we can find out the domain of this function f of x. So let us take the domain of f of x as d. So d is the intersection of d1 and d2. So by intersection, we mean that we have to identify only the common values of x satisfying both these functions simultaneously. So now let us represent these two domains on the real number line. So here we have minus infinity, here we have plus infinity, right? So here we can write 0, and here we have 1. So x belonging to this interval, that is 0 to 1, it may be expressed or it may be represented like this. So here we have this region, that is from 0 to 1, and remember these 2 points are also included in the domain of the function square root of sine inverse x, right? Okay, so now let us represent this domain d2. So d2 is r minus half. So here we can take this number, that is 1 over 2, that is half. So this domain d2, it goes from minus infinity to half, and remember this half is not included, so we'll make a circle over here and we'll exclude half, and then we go from half to the entire this positive real number line, right? So here we have from minus infinity to half, and then we have union, and then we have half to plus infinity, right? So this is d2, and here we have d1. D1 is the interval 0 to 1, so this is d1. So now the common region is from 0 to half, that is from we can write 0 to half, and here half is not included, and then we have the union, and from here we have half to 1, right? So here we have half to 1, and 1 is included, here half is excluded, right? So this domain D is given by the union of these two intervals, that is 0 closed, half open, union half open, 1 closed. So if we look at this real number line, then we can see that the region from here to here is not included in the domain of D1. So we'll exclude this region, and then from this point, that is 1 to infinity, here 1 is included, but the region that is from 1 to infinity is not included, right? So the common region is from 0 to half, and 0 is included because here we have 0 included, and then 0 to half, and then half to 1, and 1 is also included. So the domain is given by this expression.